Today we're going to discuss reciprocal trig functions. So going back from the beginning of this unit is how we're going to introduce this. So you had a problem like this. This is already kind of filled out. And on this we came up with, we had a point and theta, and we represent these using SOHCAHTOA. So if we have an angle, we can write this as opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, like this. So there are three more trig functions that we're going to look at, and those are called cosecant, secant, and cotangent. You guys have probably heard these before. These are reciprocal trig functions to the ones that we've already looked at. So cosecant is always going to go with sine. Secant goes with cosine, and cotangent goes with cotangent. The way I like to think about this is it almost seems like the cosecant and secant almost seem like opposite. Like cosecant almost sounds like it would go with cosine. Secant almost sounds like it would go with sine. But in all reality, it's opposite of that. So that's kind of how I remember it, if that helps. Reciprocal means to flip. So cosecant of theta is just 1 over sine of theta. Secant is 1 over cosine, and cotangent does go with tangent. So here we already have this problem. 12 over 13, 5 over 13, 12 over 5. What would be the other three trig functions that we just talked about? The cosecant, secant, and cotangent. Well, if cosecant is the reciprocal to sine, then that would just be flipping that fraction. If it's 12 over 13, then it's 13 over 12. Secant is the reciprocal to cosine, so that would be 13 over 5, and cotangent is the reciprocal to tangent, so the 5 over 12. So you're literally just flipping those fractions. We also had one like this where we did, this triangle is kind of already filled out with all the information on it. We found this information earlier and wrote sine, cosine, and tangent. Looking at this, sine of theta would just be 4 over square root of 20. Cosine would be adjacent, so 2 over square root of 20. And then tangent would be opposite over adjacent, so 4 over 2, which is just 2. And I'm using my signs here based off of my ordered pairs. So my cosecant is paired with my sine. That's the reciprocal for sine. So that would just be square root of 20 over 4. The other secant would be flipping square root of 20 over negative 2. And the tangent would just be negative 1/2. Okay, so in your notes, I want you to fill out this for today's stuff. So we're going to use this to find all 6 trig functions, values for all of those. So find all 6 trig functions of theta equals 60 degrees using the unit circle. Well, if I have the sine of 60 degrees, if I know that that's square root of 3 over 2, then the cosecant should be 2 over square roots of 3. Cosine of 60 is 1/2, so secant should just be 2 over 1, which is 2. And we're not going to rationalize our denominators for these. Tangent of 60 degrees is square root of 3 over 1, so 1 over square root of 3. And that's all there is to it. So here we're going to find the exact value. Okay, so what is the cosecant of 180? Well, I would like to think about this in terms of sine first. So what is the sine of 180? And then just write the reciprocal to that. So the sine of 180 is 0. So this is 0 over 1. So then the reciprocal to that would be 1 over 0, which we can't divide by 0, so that would be undefined. What's the secant of pi over 3? Well, secant is paired with cosine, so what's the cosine of pi over 3? It's 1/2, so therefore the secant of pi over 3 would be 2. The cotangent of 135, what's the tangent of 135? That is negative 1. So then if that's negative 1 over 1, then the cotangent of 135 would just be negative 1 over 1, which is just negative 1. What's the cotangent of 2 pi? So this is also 0 on our terminal side. So full rotation, or where we start from, the tangent of 2 pi let's see, what would that be? That would be the 0.10. So I do have 0 over 1. That would be the tangent. So the tangent of that would be 0. The reciprocal would be 1 over 0. So that would also be undefined. The secant of 300. So we're looking at the cosine of 300 degrees. That is in quadrant 4. So, and that has, I guess I didn't really show this a whole lot here for some of these, but the cosine of 300 is in quadrant 4. Let's think about that. Quadrant 4, that is 60 degrees. So our reference angle is 60 degrees. So what is the cosine of 60 degrees? The cosine of 60 degrees would just be 1/2. So then this, and we're in quadrant 4. So cosine is positive there. So this would be just 2. The secant of 300 degrees would just be 2. Cosecant of 4 pi over 3, we're looking at the sine of 4 pi over 3. So I didn't really show my work like I did on some of the ones from yesterday. But in my mind, I should be thinking, okay, what is the sine of that thing? 4 pi over 3. And then next, if I'm given it into radians, I'm asking the question, am I almost 1, more than 1, or almost 2 to figure out that quadrant. This would be more than 1, so that would put me in quadrant 3. My reference angle is pi over 3, so I know that sine should be negative. And if sine's negative, cosecant's going to be negative. Those are reciprocals of each other. So the sine of pi over 3 is just the square root of 3 over 2, the y value at pi over 3. So then cosecant of 4 pi over 3 would just be negative 2 over square root of 3. And that is all we have for today on reciprocal trig functions.